Hi guys, well in this week's video we're going to be going over the wiring for the Altaros turret. Now originally I installed the C10 board from CNC4PC on my G0602 and we're going to be using that to wire up our Altaros turret. The components we're going to need for the Altaros turret, we're going to need 12 volt power, we're going to need a single channel relay. Now this is a 5 volt relay. We're going to need an air compressor to supply air and optional coolant. The installation for the Altaros turret is very simple. That's one thing I really like about this turret. It's pneumatically driven, so you only need to supply air and a couple of electrical connections to make the turret work. So let's go over the wiring. So we're going to be supplying 12 volt positive DC to our common terminal of our relay, and then over to our proximity sensor on the brown wire. Now this is connected internally to the turret, but I've separated it here for illustration. Next we need to connect our negative 12 volt negative to one side of the solenoid located on the turret, and the other wire needs to go over to our blue wire on the proximity sensor. Our second wire from our air solenoid needs to go to the normally open terminal on the relay, and that's got our air solenoid connected as well as our power to our inductive sensor. Now the black wire is our sense wire on the sensor. Because the C10 requires a 5 volt TTL logic, we're going to have to reduce the output of the inductive sensor, which is 12 volts, down to a voltage range that we can use for the C10. In this case, we're going to be using a 10,000 ohm resistor. That's brown, black, orange, and gold color codes. And that's going to drop the voltage around a high of 3.78, 3.79 to 0 on the low. And that will activate the input in Mach 3. Okay, now that we have our inductive sensor wired to input 12, we can now wire up our single channel relay to activate our 12 volt solenoid. So we're going to come out on output 8 on the C10 and go over to the input terminal on the single channel relay. On the C10, I'm using common as 5 volts, so we're going to connect the common terminal next to output 8 to the DC positive, and then we're going to connect the DC negative to our 5 volt power supply common. Of course, we need to connect our air. Now the air needs to be 65 psi to operate the turret, or 5 bar I believe, and of course optional flood coolant. It's pretty straightforward connecting up the wiring. Now let's take a look at the settings in Mach 3. Alright, so I'm out at the G0602. I've got the turret all wired up. It's functioning correctly. Let's take a look real quick at my wiring. Now this may look a little confusing because I have modified this box 3 times. First I added the C6 for spindle control. Next we upgraded to the closed loop stepper motors, which these are great. I really love those. If you're interested in that, check out that video. There's a link for these particular closed loop steppers. And then now we've upgraded with the turret. So what we did was we added this single channel relay. I just kind of stuck it in here at the bottom for the moment. I'll probably just stick a screw in there and mount it right there. I apologize for the wiring. It's just I haven't really cleaned this up because I've just been adding stuff to it. So what we did was we've added in this particular wire here. This goes out to the turret, and so we have 5 wires. We have 3 wires going to the inductive sensor, and then 2 wires on the back side here. I think you can see those 2 wires, black and red. Those go up to the solenoid. So we have our input coming from output 8 going into our solenoid, going into our relay here to turn it on. We have our common, which in my case is the power, because I have my board set up for common equals 5 volts. And then we have 5-volt common, which is this white wire going up to our terminal board here. So we have our input, our 5-volt common, and our 5-volt positive coming from the common terminal on the C10. I'm sorry that sounds real confusing, but that's the way I have my C10 connected, is common equals 5 volts on my output terminals. Next we have our inductive sensor. So we have our power, 12 volts going out to the sensor. We have our 12 volt or our common terminal on our terminal board here coming from our power supply, and then our input is our black wire here, and it's going into pin 12. And right here you can't really see it, I've got it all shrink wrapped, but this is a 10,000 ohm resistor that's in line here to reduce this voltage to enough, down enough so that we can use it on the C10. That's pretty much it. It's pretty straightforward. Let's do a couple of tool changes and you can see it in action here. We're going to 8 here. And then back to 1. Now the turret only rotates in one direction, but that's okay. You can see it rotates pretty quick. The great benefit about this turret is the fact that I can walk away from the machine once I hit cycle start, and I don't have to keep coming back to do a tool change. I run parts that require several tool changes, and the cycle times are real short, so I can't even leave the machine. I'm constantly changing tools, and when you run 100 parts with a 1.5-minute cycle time and you've got 3 tool changes, it really makes for a tiring day. So it's a lot easier to have to just put a new piece of material in there every 1.5 minutes rather than have to change the tool. The turret's really going to come in handy for those types of parts. Now let's go into Mach 3 and let me go over the setup, and I'll go over the tool change macro that's provided by Altaros. Okay, first we want to go to config, general config. Right here. We want to make sure auto tool changer is selected. I also like to make sure that tool selections persistent is selected, persistent offsets. So these will maintain the tool offsets for the last tool that was used, and also maintain the last tool that was used should you come out and go back into the program. Click OK. Next we want to go to ports and pins. So for our input signals, we want to set up input number 4. This is the inductive sensor. I have it set for port 1, input 12. We want to make sure it's enabled. Next we want to go to output signals. We're going to be using output 6. Output 6, we want to make sure it's enabled. We're using port 1 and whatever pin number you happen to have available. In my case, I'm using output 8. Now for the flood coolant, if you've already have flood coolant, you don't need to worry about that. If you don't have your flood coolant set up, then you can set that up. I happen to have mine set up for output 4, pin number 9. We want to click OK. We also want to make sure we go up to configure, save settings, so that we can save all of those settings. So that's pretty much it. We just need to set up our output for the solenoid here, our output for our flood coolant if you don't have that already set up, and our input for our inductive sensor, which is input 4. Let's go to the Diagnostics tab, and you can see input 4 is active. Anytime you are on an odd position, 1, 3, 5, or 7, you should have an active input 4. When you go to position that is an even position, position 2, you can see that it's not active. That's how the turret determines where it is, whether it's in an odd or even position. Alright, so we want to check and make sure output 6 is activating to rotate our turret. We're on position 2, so we're going to move to position 3. And we can see that our output 6 activated, and we also got active 4 for input 4 because we are on an odd position 3. So now that we know our turret's working, let's go and take a look at the tool change macro. So here is the tool change macro provided by Altaros. I've went through this and scanned through the tool change. They've got lots of checks and balances to make sure that the turret is in the correct position. One thing interesting is they're using this mathematic calculation, this modulus 2 here, to determine whether or not it's in an odd or even position. If it is in an odd position, 1, 3, 5, or 7, then this input 4 should be active, so it's going to check to make sure that that is the case. And then it's going to get the selected tool, and then here it's going to activate the output to rotate one position. Then after it rotates, it's going to check input 4 and set a couple of variables. If the variables are set correctly, meaning that the turret did rotate accordingly, then it's going to move on. It's going to cycle back through. It's going to add one number to the K position. K is the turret position. Again, it's going to do a couple of checks to make sure that if the K position number is odd or even, it should be input 4 should be active or deactivated. It's going to keep repeating this process until the selected tool is the current tool number. Pretty clever tool change macro, and I've tested it out. It works really well. So let's do a few tool changes. We'll see how it works. So we're currently in position 3 here. Alright, so let's take a look at a couple of tool changes here. So we're in position 3. I'm going to type in T0404. We're going to move to position 4. T0808. Now, for those of you not familiar with tool change calls on Mach 3 turn, 08 is the tool number, and the second 08 are the tool height offsets stored in the tool table. So let's go to tool position 8 here. Alright, and one more. Let's go back to tool 1. Works really well. Now, let's say you're running some G-code. There's a couple of things that you need to be mindful of with the Altaros turret. Alright, so this is a part here that I run frequently. It's just a small part. It has 3 tool changes. We're using tool number 2 here. We're going to make a few passes. Then we're going to thread it, and then we're going to part it off. Ideally, I should swap these tools around so tool changes would be quicker and it doesn't have to go all the way around, but for demonstration purposes, I think we'll be okay here. With the Altaros turret, we need to make sure that we start Mach 3 in our program. We start in position 1 with tool 1 selected at the beginning when we start up our machine, because we want to make sure that the macro and the turret and everything is in the position. The macro doesn't really know whether it's tool position 3 or tool position 1, because both of them will give you the input 4. So at the very beginning, we want to make sure that we are on tool 1. So that's the first thing that you need to be mindful of. The second thing we need to be mindful of is in our G code, we need to edit it so that it moves to a position that the turret will clear the chuck and the stock so that it can rotate. Now currently I only have tooling in here that goes in this direction, but if I add some tooling blocks on the side with the drill bit that sticks out, I need to make sure that that drill bit can rotate and spin freely and clear the material and the chuck. We're going to have to back the turret up so that it clears everything while it rotates. So this is kind of extreme, but I wanted to just kind of show you here. So what I'm going to do is I'm going to edit my G-code so that before a tool change we're going to position the turret so that it is free from any obstacles. Alright, so we've edited our G-code there to move to a position so that we can rotate to tool number 2. And this position should be good for all 3 tool changes. So I'm going to paste that right here in front of this tool change as well, and again for the last tool change here. Alright, now this is some G-code that I had when I was using my quick change tool post, so let's see how it runs. Alright, so we're going to save this. Alright, you can see these real long movements here. These are for the turret. So let's just go ahead and run this G-code and we'll see how this thing works. Here we go, cycle start. So we're moving to our tool change safe location to rotate our turret. We've got tool 2 here. We're going to do some profiling. Moving to a location to change to the next tool here. We're doing tool 4, which is a threading tool. So this is a threading operation here. And we're going to go back around to tool number 2, which is our parting tool. To part the part off. Alright, so you can kind of see how the turret operates. We've got it wired in. We've got it operational. There, move out of the way again. Sorry, I didn't have enough air there. My air compressor had turned it off so it would keep cycling. So you can see we've actually aired out because it didn't finish its rotation here. I guess that was a good thing to show you. So it hit a reset here. So what I'm going to do is I'm going to let this air compressor charge, and then I'm going to move it back to position 1 and we'll restart this G-code. Sorry about that, but it's good that you can see that the error is out if something was to occur, and it stops and pauses your G-code. There's still a lot that I've got to do. I need to machine some coolant plates for the tools here. I need to machine some outside blocks for some tools for drill bits, boring bars, that sort of thing. And you can see here that for this particular part, I don't really have these tools in the correct order for the most efficient tool changes. So I've got to get all that stuff sorted out. So in next week's video, we're going to be doing some machining some coolant plates. So stay tuned for that. I'm still gathering up tools so that I can actually machine some parts. And that will be coming up in a future video. Guys, if you're new to my channel and you're just tuning in, click on that subscribe button down here below. That way when I post a new video like this one, if it's something you're interested in, you can stop by and check it out. If you're interested in the Altaros turret, be sure to check out the link in the video description. They have a couple of machining videos so you can see the turret in action. As always, guys, please feel free to ask questions, make suggestions, or leave comments. Thanks for watching. Please subscribe. Thumbs up if you like the video, and most importantly, be safe.